In this video, we are talking about scientific notation and standard form. Firstly, let's define scientific notation and when we will use it. So scientific notation is a number written in terms of powers of 10. Okay, I will show you some examples in a few minutes, but we use these to write really big or small numbers. The numbers we typically use, counting numbers, rational numbers in general, are called standard form or standard notation for the purposes of this lesson. So you'll either be asked to write in scientific notation or standard notation. Scientific notation, really big or really small numbers, because we often deal with really large numbers or really small numbers when working in science in particular. For example, the distance to the sun, the distance to certain stars in the universe, so it comes into play for super large numbers in those senses. And even really insanely small numbers when we're talking about, for example, the size of an atom. Okay? So, what are some examples and what are our rules? First of all, our rules. The rule is the first number in scientific notation is less than 10 and greater than or equal to 1. The second number is a power of 10, so we write times 10 to the power of whatever exponent it's supposed to be, so negative or positive. If we have a negative exponent, we have a really small number. If we have a positive exponent, we have a really big number. The general format for scientific notation is a number, decimal, any other numbers happen here, remember, less than, between 1 and 10. Times 10 to the power of another exponent. Negative is small, positive is big. Okay, so this is our general format. Let's take a look at some examples. Our first example in standard notation is 1,200,000. So what I'm going to do first is I am going to move a decimal place over next to the 1, because I want this number, this first number that I have, between 1 and 10. So I have 1.2. Now I could write all of these zeros, but the whole point of this is to make the number a little smaller and a little bit easier to work with. So as long as they're not placeholder zeros, meaning there's some other number over here that is equal to something else other than 0, then I can just drop them and just kind of ignore them in my final scientific notation. Okay, so I have 1.2 times, and this scientific notation is the only time I will encourage you to keep using that little X for times. Normally I will encourage parentheses or a round dot, but for scientific notation we do typically use that X, times 10. And now this number is a large number, so this is going to be a positive exponent. And how I get that exponent is by counting up how many times did I move my decimal to get from its original spot at the end of a whole number to the new location between the first 2 digits of the standard notation. Okay? So I moved this, I'm going to count it, 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. So my exponent will be a power of 6. Okay? Now to turn this number back into standard form, I would start by writing my 1 and my 2 with my decimal. And I'm going to move the decimal 6 times, since this is positive, to the right. So I go 1, 2, 3, 4, 5, 6. That would be where my new exponent would go. I will put my placeholder zeros back into place, and if you count it up, you realize 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I ended up right back where I started. Another example is if we have a really small number. So again, I'm going to start off by writing my first number in my scientific notation with the first whole number, followed by a decimal point, followed by any other numbers that are not zeros or placeholder zeros that follow. Now I am going to write my times 10 to the power of question mark. Because this is a very small number, that tells me I'm going to have a negative exponent because I am moving it to the right when I am adjusting to scientific notation, okay? If you remember from our exponent lessons, a negative exponent means I have a fraction. So 1 over 9.73 times 10 to the power of something, I have a small number that's less than 1, okay? So when I am finding out what my exponent is, again, I'm going to simply count up how many times I have to move the decimal. Not just the number of zeros, but how many times I have to move the whole decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I have 9 and 73 hundredths times 10 to the power of negative 10. Again, to move this back, I would write my 973. I have to move the decimal from this location, and I'm going to move it 10 times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put my decimal place here and replace all the zeros that were placeholders that we ditched to write it in scientific notation. Okay? So now we're going to start with scientific notation. I want you to write on your paper if you think this is a big number or a small number. And we are going to start by making this small number because it's a negative exponent. I'm going to write my 897 over here, and I'm going to move my decimal 5 times. 1, 2, 3, 4, 5. Replace my decimal, replace my placeholder zeros, and my final answer should be 1, 2, 3, 4, 8, 9, 7. And again, to move back to scientific notation, I would move that decimal back over between the 8 and the 9. Because remember, the number here in this first spot has to be between 1 and 10. It can be equal to 1, it cannot be equal to 10. We have to have one digit before a decimal place. Okay. This time we have a large number because it's a positive exponent. 4 and 1/10. I'm moving my decimal 4 times. 1, 2, 3, 4. And I have 41,000 as my answer. When it's positive, I know that I'm going to have a larger number, and I'm going to move my exponent to the right because I'm multiplying, essentially, in this case, 4.1 times 10 times itself 4 times. 10 times itself 4 times. 1, 2, 3, 4. Oops, I accidentally put an extra 1 in there. Okay. So 4.1 times 10,000 is going to give me a larger number. If this was a negative exponent, for example, 4.1 times 10 to the negative 4th, right? I would be multiplying 4.1 times 1 over 10,000. Okay, so if we just remember those negative and positive exponent rules, that will help us with remembering which direction to move my exponent. What happens when I don't have a decimal showing in my scientific notation form? Or if I don't have it showing in standard form? Well, what I'm going to do is I'm going to look at the whole number. Remember, a whole number always has a decimal at the end, right? I could write this as 1.0. That's still 1. I could write 1.00000. That's still equal to that 1. So we can't change the value of the 1. We want to make sure that decimal is right at the end of wherever the whole number ends. Okay? Now in this case, I would start with my 1 and my decimal place. I'm going to move it 7 times. I want you to think in your head, am I moving right or left? Answer that question. Hopefully you said right because this is a large number, so we want to make this bigger. 1, 2, 3, 4, 5, 6, 7. That last one ended up a little bit bigger than I meant, but you get the picture. 1, 2, 3, 4, 5, 6, 7. And I am going to write some commas in here. to help me see that a little more clearly, that it is 10 million. Again, I'm going to check for where my decimal goes. Remember, with whole numbers, it goes at the end. This time, I'm going to move to the left. I can kind of use that negative sign as an arrow almost too, telling me that I'm moving to the left. Ready? 1, 2, 3, 0, and 4 thousandths. So I want you to pause the video in a moment and answer the question, what is wrong with this number right here, before moving on. Leave some space to answer the question, how do I fix it also. So hopefully you pause the video to answer the question. And what is wrong with this is that this number right here is not less than 10. Remember, we always want to have one digit before the decimal place. Okay, so I need to move this from here to here to fix it. Okay, 12 and 97 hundredths needs to become 1 and 297 thousandths. So pretty simple here. I move the decimal over one time to the left. But that also means I need to do something about this exponent here. Okay? If I make this number smaller, I'm going to make this number bigger. Okay? Because I have to move the exponent, move the decimal one more time to finally get it out to its original standard form. If I move the if I move this number to make it bigger, for example, if I have 0.54 in this left side of my scientific notation, if I move it up, then I move my exponent down. Okay? So if I change the left side, the numerical portion, to make it smaller, I make the exponent larger. If I change the decimal to make it larger, I make the exponent smaller. Okay, so to formally, completely fix this, I would write 1 297 thousandths times 10 to the power of 5. I made this number smaller, so I make the exponent bigger. Good luck. Go practice. Let Mrs. Jackson know if you have any questions, and have fun.